Hello, everybody, and thank you so much for having me today at the Australian CIO Summit. And my talk is about growth through connections, and in particular, it is about the questions for shifting from anything over 5G to all intelligence connected with beyond 5G systems, and in particular, I'm thinking of 6G. So a couple of words about myself. I have been active in the information and communication technology field for more than 25 years globally. And my experience is especially at Nokia for about 15 years and 10 years at Huawei Technologies. And I'm currently serving as a CTO and CSO at Huawei within the Asia Pacific region, as well as I'm contributing to the 5G IMDA task force as chairman, and I'm also continuing, my work as an academic at a University of New South Wales as a adjunct professor. Now, I'd like to start from introducing you where we are today with 5G, and this figure, it is about the current assigned spectrum for 5G and the live networks and planned 5G launches. As you see here, we have more than 128 operators that have received spectrum in the 3 bands, so namely the low band below 1 gigahertz, mid band normally around 3.5 gigahertz, and then in the high band which is above 6 gigahertz. Particularly I'm thinking of the millimeter wave at 26, 28 and so forth gigahertz. Most of the locations has been on the mid band. Now, as we speak, we have many operators that have already launched 5G. That has happened also here in Australia. And we have more than 110 operators that have planned to launch those services. Equally interesting, it is the number of connections already in place and at a global scale. So as you see here, this report from the GSMA and GSA, which have consolidated in a single slide, shows that at the end of last year, we had already more than 200 million connections, and expectations to achieve about a quarter of the planet connected, namely 1.8 billion connections by 2025. If you look into the details, see here, most of the connections are coming from China. So we have 202 millions out of 234 millions in China. And if you look at the 2025, we have more than 800 millions out of 1.8 billions. Equally, in China, here you may see also the operator capex within the range 2020-2025. So it is an investment of more than 200 billion in China. Of course, it's not just 5G happening in China. So if you look at the adoption expected by 2025, we have that most of the adoption, same percentage, would be North America, followed by Europe, and then, of course, the Asia Pacific region. Now, looking at the announced 5G devices by form factor today, we have that we have already available commercially more than 274 smartphones, so there's plenty of choice. We have more than 100 a fixed SCP for fixed wireless access in other form factors, such as industrial enterprise routers with the connectivity to 5G tablets, hotspot, and the possibility of implanting models on other type of platforms such as drones, vehicle, robotic platform, and so forth. And here you may see the representation of a pie chart where most of the devices available are a smartphone followed by the CP for fixed wireless access. When we talk about the 5G and 6G and and how the technology will evolve, we may refer to the 5G technology roadmap developed by the 3GPP, the Third Generation Partnership Project. That is the organization that defines the technical requirements and deliver the technical specification that are then standardized globally by the corresponding organization. So you see from this graph, we have that 5G in its release 15 was completely standardized and specified and standardized by September 2019, including its standalone configurations and following the earlier configurations such as the non-standalone, and also the wireless interface was already completed back in 2017. This technology supports and enhances the mobile broadband communications. Release 16 was completed last year in September, and it enhances the mobile broadband experience and introduces many features to achieve an ultra reliable latest communication services. Or both of them, they full meet the ITU requirements, in particular the ITU vision that was formulated back in 2015. Now, as we speak, we have the specifications. We have study items and completed and now started the work items. So the technical specification of the release 17, and that version will, that release will enhance further the EMBB URLC, but in particular, will address the problem of integrating millions of connections over a square kilometer. Beyond that, we will start working on new use case categories, and that will lead to the definition of study items for 6G and work item for 6G, leading to the system completions, at least in terms of specifications, by 2030. Now, looking at the supported features from release 15 to 17 and beyond, I have made this slide that gives an overview of the performance compared to the narrowband IoT and EMTC coming as over the 4G, say technical, beyond the 4G technical specifications, namely the LTE. And I'd like to remark the fact that this communication services will continue regardless the enhancements we may have with the new radio. So here you have the differences, and in particular, you may see when those two services or usage scenarios will be supported. First observation I'd like to make, that is the fundamental difference between the 4G, so LTE, and the new radio, is the fact that the new radio supports all spectrum that ranges from 400 megahertz up to 52.6 gigahertz. This is basically already in release 15 and 16, and now we are thinking of modifying the waveform to reach out up to 71 gigahertz. The differences between these two technologies are, in particular, as I said, Release 15 define the basics and the fundamental enabling technologies to support and enhance the mobile broadband services. Here you have a list of those. In particular, I would like to mention that the massive MIMO beamforming is supported by default, so it's coming along with the new radio, and it also supports network slicing and provides a baseline for security controls and assurance end-to-end. Then Release 16, it is the main focus is to address the industriality, and it supports a nice spectrum, positioning a system down to 3 meters, whereas the earlier generation focuses only on the support of GPS. And in addition to this, comes along with an integrated access and backhaul. And in particular, we have that the technologies for vehicle-to-X communications are also supported. Security is enhanced towards the IoT and network slicing. Then with Release 16, we have the focus that shifts towards the consumer IoT. And here I'm thinking of critical IoT or wearable devices. It further enhances the positioning system. And in addition, it brings as an integral part of the access network, the non-terrestrial access network. And in this case, we are speaking of GEO and LEO satellites constellations. It also supports MBMS and the multi-access computing for 5G communications. So 5G really improves the security controls, and here you have examples of improvements in terms of controls and assurances. We may say that the LTE is really secure as a system, but we have some specific enhancements. And here I'm thinking of the possibility of encrypting or concealing the identity of the end users, so the privacy is preserved even prior to the registration of the terminal. And we may also see we have the possibility of introducing integrity in the user plane between the terminal and the access network. And it is all based on the concept of secret share keys that are made available only in the core network. So in the authentication repository function and the mobile terminal, based on these keys, we are able to generate all the remaining keys, both for achieving appropriate authentications of the communication, even up to the application functions and the encryptions or integrity of that particular interface. Looking at the other interfaces between the CU and DU, or between the different network function virtualized in the core network, the standard also proposes a specific mechanism for encryptions as well as authorization and authentication of the communication. Here you have examples of protocols recommended. Beyond this, we now have for the first time the possibility of complying with specific network equipment security assurance schemes. That is the work done by GSMA and 2GPP that have finalized already the first version of the specification, so that vendors can get an audit report of their product development and life cycle processes, as well as the test equipment, and obtain a test report that demonstrates the fact that the element or the equipment in general complies exactly with the security controls and functions the standards mandates. And yeah, it is of last year that Nokia, Ericsson, and ZTE and Huawei already got an audit report. I'm thinking of Huawei. Huawei has already received the audit report for both the radio access core network, and it is of December last year. It got also the test evaluation report for the LTE and the new radio base stations. Now, looking towards 2025, what kind of requirements and new user scenarios are we expecting? I have made this slide which capture the main and most important directions. So beyond the EMBB, MMMTC, and URLC, we're now thinking about uplink-centric broadband communications, real-time broadband communications, and harmonized communications and senses. So very important here is the work done to meet and support services for machine and massive type of traffic communications. Now, starting from the uplink-centric broadband communications, I'd like to introduce you the 5G to business applications. They are already available and they will come commercially available, say, in a few years from now. As you see from this graph, we have different type of Internet of Things. We speak about massive IoT, broadband IoT, critical IoT, industrial IoT, depending on the devices that we connect. The traffic is especially uplink, and that's why we talk about uplink-centric broadband communication. So we are currently having the possibility of connecting the IoT with decent speeds. And here you may see the supported bit rates. We would then have the possibility of offering other type of applications. Here you have example vertical sectors, thanks to the fact that the system will support reduced latency and improved reliability. Real-time broadband communications example are the most important is the XR, that stands for virtual reality and augmented reality. And that here is expected that this particular service will grow exponentially by in the next, say, 2 to 3 years. Here you have more details coming from Gartner. And what we can see from this figure is that the shift will be from the support of the 4K for both highest 100 megabit per second bandwidth, and we will be able to achieve a 1 gigabit bandwidth with latency less than 10 milliseconds, which will allow us in particular to enjoy, say, a service such as VR for socializing, VR for any kind of vertical industry, in particular integrating the possibility of dealing with digital twins. And an example of those are the smart cities. Harmonized communication and sensing, also important is to consider the possibility of connecting unmanned aerial vehicles. And here you may see the requirement that the system has to support in order to enable these communications. And you may also see here the different type of digitally connected elements. And here you have a view of the market and the volume of elements expected to be connected by 2025. So we are expecting more than 50 million elements connected, addressing revenue more than 72 billion globally. In order to achieve realize this vision, it's of course intended we need to have a proper regulatory framework in place and applications and control enabling platform so that all those services can be handled efficiently. It's also important to say something about, still within this category, about the vehicles to X communications beyond 2025. So by 2025, what we are expecting here is we will achieve the level of conditional automation thanks to the deployment of 5G on supporting eMBB and vehicle to X communications. And then by 2030, we will expect advancements towards the full automation thanks to the deployment of 5G for URLC and the enhanced vehicle to X protocols. So what vision do we have of the system by 2025? So it is a system that basically supports all possible services and service applications, and it is a technically feasible and potentially business viable for all possible scenarios. And here you may see example representation about personal communication, what you get at home, what could be rendered in the cars, and in particular all the industry potential applications. In order to achieve this vision, we need to have the realize this vision. We need to have the right strategy, and the strategy, what we are proposing, consists of 4 main pillars, and those pillars are represented here below. So we need to know how to deploy the system and meet specific service applications requirements. For B2C, C stands for consumer, B2B, so means to business, and then to home. We need to integrate all spectra, so means bandwidth in the sub 3 gigahertz, sub 6 gigahertz, and below 100 gigahertz. We must absolutely simplify the site. And in particular, we need to revisit completely the network architecture. Starting from the criteria and the services we need to support, the slides I present in high level the performance requirements in terms of resolution, downlink, uplink rates, latency, reliability, positioning, what we may enjoy today and what we target to achieve by 2025. You may see that the requirements are really much more stringent towards 2025. That would allow us to offer much better communication services, reduce latency, and with an increase of the reliability. And here you have examples of different robotic platforms that today we may achieve latency below 50 milliseconds. We will target to be, for other services, it's the requirements to achieve less than 10 milliseconds, 2 ways, and reliability of 5.9, which is currently basically not possible, because one of the features we need to have in place, it is the multi-connectivity, and currently we just achieve dual connectivity between the LTE and the new radio. Yes, the BAT spectrum, our strategy is to enable a 1+N ultra simplified 5G network. One will be, say, the core bandwidth where the new radio will transmit, at which the new radio will transmit, and the other one will be especially dedicated to the LTE, in carrier aggregation dual connectivity, to boost the radiation and transmission capacity at the interface. Here you have examples of the different deployment scenarios for the spectrum that has to be used or may be used to achieve those particular communication services in different areas, such as urban and suburban area, as well as hotspot with the possibility of using millimeter waves or higher spectrum and larger bands, and then rural wide coverage areas with a head of the sub 1 gigahertz spectrum. Here you may see the possible speeds that can be achieved, and by aggregating the spectrum in a combination of 1+N, it is possible to achieve really very, very high speeds, low latency latency, and therefore support up to 12, 24K AR, VR experience, which is a far much better than what you are experiencing today as a consumer, where the resolution is limited to 4, maximum 8K. Sites must absolutely be simplified. Simplification of the site means to get rid of pretty much everything you're having today in place, which is cumbersome, which is expensive, which pollutes and has all the problem, and it's extremely costly for our case. So the target by 2025, actually, looking at our organization, we're already having solution from this year. We'll be able to shift from multiple antenna towards and use a single blade antenna, which supports the upper part, say the new radio transmission, the lower part, or the communications multimode sub 3 gigahertz, including the new radio refarming. We have a blade microwave antenna that supports the band together with the traditional spectrum, and then we are now capable of integrating all those radio remote units into a triple and dual band configuration, and then easily connect, place them on a mast and connect them to the corresponding passive antenna. The BBU is a one BBU, so baseband unit that serves all the modes and can be achieved by a simple soft upgrade. The power at the battery has been also considered into a blade configuration. It allows us to do a multiplexing and resources in terms of energy sharing between the different communication system, and therefore save energy dramatically and reduce costs. Here, you may see we have reached out more than 50% saving. Consider that this is the most expensive part, lucrative part also of the 5G system. Looking at indoor configurations or hotspot configurations, what we think of now is to use the system which which utilizes the same baseband unit. So the baseband unit, it is pretty much, is exactly the same. And then what we do here, we are having in place a radio remote hub that will allow us on a CPRI or CPRI interface to reach out multiple Pico RRUs, and those RRU can work in beamforming or in a configuration or multi-user MIMO, allowing us to achieve positioning systems of a resolution of 2 meters, which will basically make it possible to connect robotic platforms pretty much of any kind, and improve the downlink and the uplink capacity of a factor of 3 to 4. The architecture we target by 2025, it is an intelligent system which consists of multi-access type of solution that supports all scenario over a single site type of configurations. Here you may see the different deployment scenarios using fiber as a front all way of connecting the active antenna units and the base stations, and then or using microwave, or even including the possibility of having an integrated access and backhaul. Then you have the fully distributed intelligent mesh solutions, which it is flexible and has all the capability for us orchestrating the system end-to-end, support net slicing, in particular deploy artificial intelligence all over the places, from the devices to the age and the different distributed data center. And here you may see example of these technical challenges we are facing today and the corresponding technology breakthrough. I've just mentioned a few of them. So what we're thinking now is to deploy the machine learning pipeline, and therefore each of the function in place has to be orchestrated. We are using a number of AI-enabled applications, so we would need to be able to efficiently and properly provision them. The system has, in terms of machine learning pipeline, many potential, say, vulnerability. Therefore, we are starting out and having in place at the same time solutions that are really trustworthy, they are resilient, and in particular, they preserve privacy when we deal with different type of data, and which may or may not involve PII. So, yeah, person identifiable information. And what we're thinking currently is that the machine learning could be the potential. The machine learning can be further enhanced by making it work with the machine reasoning. Now, looking beyond and thinking of how the system could further evolve, I have captured on a slide the key trends, or if you want, the key challenges and the potential solutions to meet those the corresponding requirements. So my vision is that simple, all intelligence will be connected and with zero trust, and through the digital twinning using 5G, 6G, and in particular, the machine reasoning will meet machine learning at the edge of the network, being the edge anything that is around and user practically. Looking at the 5G today would be on the Mac, so the multi-access computing platforms. And yeah, because we have to basically address the challenges we are having today. In particular, you may think of the costs that artificial intelligence has. And as you may see on this slide from the IIT in Italy, so there was a presentation by Roberto Singolani and Giorgio Metta. You can see that how ineffective and also inefficient artificial intelligence is today, and the power cost per operation, it is between 1,000 to 5,000 higher than in machines compared to what would cost humans to perform the same type of operations. And then, of course, you have other challenges. That means that all intelligence will be transferred to the edge and centralized. There are no other possible solutions to simply address this particular challenge. The intelligence will be therefore moving at the edge, and which means definitely no more than 150 kilometers from the device, due to the constraints we are having in delay in the propagation. So between the 2 points, so we are expecting latency below 10 milliseconds. And then, yeah, if you look at the machine learning itself, the pattern recognition techniques, there are many problems and limitations and biases. So we need to find a way to improve their performance and reliability. And one way to do that is to make the machine reasoning algorithm work together with exchange services with the machine learning. Then it's of course a must now to digitalize pretty much everything. So not only business processes, but also what we see and touch. And that is necessary for us to improve the efficiency and improve the productivity and reduce the CO2 or green gas emissions by 2025 or latest by 2030. And another important thing that has to happen is the profound shifting paradigm now from the 5G to beyond 5G and 6G, because of what we think of designing now. It's not anymore a system that we connect the machines, but we need to find a way to proper connect the intelligence. So the visions and the revolutionary goal we are having with 6G is simply to shift from anything connected that is the mission, the goal, and what practically 5G achieves to connect all intelligence. And what we are expecting is that the mobile communication system will be the fundamental, so the connected networks would be a fundamental enabler for the proliferations of artificial intelligence. And the network itself will practically be used as a sensor, as the eyes of the different intelligent entities to augment the machine intelligence, which is a defined, and I'm defining intelligence as the ability to represent knowledge, process knowledge, and also make a decision. If any of these three elements is missing, we may not consider that particular machine intelligence. No, the vision of the 6G network is in high level represented on this slide. So the target is to connect the physical world and the cyber world, and that will be through virtual, augmented virtual reality and augmented reality. So it's going to be a system that will support different type of channels of communication. So in the downlink, we are thinking of virtual reality type of communication, VR, AR, as that will be the way of communicating between the cyber and the physical world. We need to carry the tactile signals, so haptic feedback for a full immersive interactive experience, or even holographic experience, with the possibility of have by playing with the holograms, the same thing as I had my hands on the physical elements. And then, of course, the inferencing, which means the way of carrying, transmitting, sharing the trained models and allow inference in the different path and or different device platforms. And in the uplink, the system taking advantage of the fact that it receives and transmits especially at the millimeter wave and terahertz, it will be really will have capability of sensing and learning. So in this case, we are thinking of a massive amount of data that will reach out the network, that will consist of the base stations that will transform into neural edge, and the core network will be generalized in terms of neural centers and the communications and the capability of reaching out the services will be not only using terrestrial access, transmitting and receiving points, but we will integrate the communication via the satellites. And the satellites in use will be the low Earth orbiting satellites with the altitude that ranges from 300 to 1.5 kilometers, which would allow us to achieve speeds of less than 3 milliseconds, and practically speaking means faster than the deployed fiber. And this is due to the orthodontic surface distance, which will be longer than what we could get by making communication 2 points via LEO satellites. The satellites will be very fast with an Earth rotation time of around 2 hours, and the coverage will be also massive, as the footprint expected will be between 100 to 1,000 kilometers. So the network architecture drivers or the fundamental shift in paradigm to achieve a 6G system are represented on this slide. So we need to shift from today cloud-centric system to a system that is truly AI native. We need to move from information-centric to a network as a sensor. So it will be really the sensing capability of the system that will make the difference, also with respect to what you can do with the 5G today with respect to the main goal of 6G. Security-centric today, I presented earlier how the security controls have been announced in 5G with respect to the LTE. The target will be to achieve solutions or, that meets the requirements of a defense in-depth strategy augmented by the zero trust model with security by design from day one. We will shift from a generic bit pipe as it is today to user-centric type solutions, and the end user will be coming finally, ultimately, also the prosumer. So that means the services will be not only made available by the carriers of today, but the end user, whatever the end user is, an individual as a customer, a consumer, or working from home, or an organization, will be a part of the ecosystem that generate the new services, including making available knowledge in whatever its representation will be to the broader community. Here you have an example of initiatives ongoing globally, and I'm particularly close to what happened in Europe, as I was one of the founders of 5G initiative. I have formulated with my colleagues the vision of 5G, and with my team, we have contributed to all fundamental enabling technologies you're having today in the 5G system in terms of communications, but also AI application. Therefore, I am still involved the activity on Ongoing Europe, where you may see that for the 6G within the smart networks and services joint initiative, so it's a private partnership that have made available 900 millions over 7 years, which means 200 millions more that were invested when I was in Europe with my colleagues, which, by the way, I miss so much. That ranges from the European Commissions down to all vendors, because vendors, they have a need to work together to achieve an agreement in terms of standardization, cooperate, so that we really aim at achieving the best out of the best in terms of architectures and enabling technology, but also means the carriers and the ecosystem of players that have allowed us to achieve what you have today on 5G. With that concludes my presentations. I thank you very much for having me today. I'm normally usually sharing what is public available. I can make publicly available on LinkedIn, and you may find me behind this link, and you may follow me by click on follow when you reach out my profile to stay updated and receive the latest information, especially my contributions in the field of artificial intelligence, IoT in general, 5G, and now we are starting our journey on 6G. And here you have examples of contributions that I have already made available. As of today, we have reached out more than 200,000 views and downloads on LinkedIn. With that, my presentations, and I thank you so much. And yeah, let's stay connected on LinkedIn. Thank you and goodbye.